Hello, I'm Tony.
I'm Patrick.
And we'd like to welcome you again to our show, Cave to the Cross Apologetics. And we're continuing our look at Mitch Stokes' book on how to be an atheist. And so he is working, we're working our way through this book. We've worked up to Ch.7 now.
Mm-hmm.
And in our last chapter, we saw how difficult, how hard science is. It's really what he wanted us to see, right? So he's not dismissing science. He understands it's important and it's extremely difficult. In fact, more difficult than most people think it is.
You got to come up with a theory. You got to come up with a hypothesis, which is just a theory is in and of itself. Then you have to do all the experimentations, which is really difficult. And then you have to somehow find a correlation between, does your theory say what your experiment came as a result, or were you out in left field?
Yeah.
And were you the only ball player out there?
Yeah.
Because you could have thought that it was going left field, and it's really going right field. And that's pretty much the extent of my sports analogy.
Yeah.
So,
yeah.
So he says,
he says, there's no recipe for finding the best theory that will adequately explain the observational phenomena. The process is rife with uncertainty, ambiguity, and subjectivity. Finding a workable theory is nothing at all like falling off a log, he tells us, right? Despite the countless possible theories that could fit the data, right?
Or the apple falling on your head.
Yeah, right. So he says all this makes success in science a matter of an enormous amount of hard work, ingenuity, and creativity, and no small amount of luck. Scientists, he then says, are legitimate heroes, right? They are heroes. And it's their heroes. That's right. It's their hero status that seems to give them the credentials to be our final arbiters of truth. So when science speaks, as a result of this, people listen, right? Like that old commercial, right? Again, it's hard to argue, he says, with success. And so that's what he wants to look at in this particular chapter. In fact, the chapter is entitled Arguing with Success, right? He says, so when we hear that science and religion are at odds or even conflict with one another, right? It's all too easy to think, then so much the worst for religion, right? Because science is successful. Again, this line of reasoning, he says, is predicated on the success of science, right? So science is successful, and we know that. You know, it's hard work, but it is successful, and so we should listen to it. So if science is telling us something, especially about God and religion and that sort of thing, we need to pay attention and, and go with it, is what he's suggesting here, right?
I mean, after all, we're talking to metallic objects that transmit our voice into electrical phenomena that then breaks it up into ones and zeros and somehow reproduces exactly, or pretty much with a small degree of certainty, what our voices sound like. And we're able to transmit it to the entire world. You take this technology, 500 years ago, and it
would be like magic.
Yeah, it would be like magic. So there's that theory that advanced technology is just no different than magic for how it operates.
Yeah. Yeah, so he talks about Stephen Hawking and Dawkins, and both of them, especially Dawkins, with his conflict analogy between reason or science and religion. Tries to make an argument about the existence of God as a result of the success of science. He says, now we can all agree that science works. All right, no brainer, just like you just said, the ones and zeros. He says, let's all agree for the moment now, so he's given some ground here, that our scientific theories really do provide significant evidence against God's existence. That is, he says, let us agree that science says or implies or proposes or suggests that naturalism is true, right? That there's no God. That's what naturalism says, right? Nature is all there is. There's no supernatural.
Right.
With such generous concessions, along with the undeniable fact that science works, do we now have a good argument to the effect that science has shown that God doesn't exist? All right, so what is the argument here? Well, we can kind of boil it down like this. Science works, right? That would be the first premise. And then science says that naturalism is true. or so says Dawkins, and folks like him, right? So if naturalism is true, then there is no God.
Right.
Right?
By almost definition.
Right. Therefore, there is no God.
Yeah.
Right? So since science works or is successful, and it claims, according to some anyway, that naturalism is true, then that shows the success of science, he's saying, implies that God does not exist. Right? So that's what he wants to tackle in this chapter. And so, as we mentioned, the name of it is Arguing with Success. How do you argue with success? Well, that's what he wants to do in this chapter. He wants to argue with success, right?
In one of our conversations online with the awesome YouTube comments, that was a critique someone had is, of course, you argue with outcomes. That's what you're given. Well, the problem with that though is sometimes how do we provide food for 100 starving people? Well, you just kill 50 of them. Then what was starving for 100 is plentiful for 50. Right. Can't argue with success, right?
Yeah, that's right.
So
Success wins.
How do you actually measure what success is? And if we're trying to find a theoretically objective truth, that's what science is alluding to the fact. To describe, how do we actually come about knowing what success is?
And more importantly, at least for his argument here, is does success equate to truth?
Yeah,
right.
And it seems like our definition of success here is minimal as well too.
Yeah. So he says, so the question is, do we now have a good argument to the effect that science has shown that God doesn't exist? And he says, clearly not, right? We need at least one other important premise, namely that what science tells us about the physical world is true, right? In particular, those parts of science that are relevant to any argument leveled at belief in God.
So again, naturalism is this idea that nature is all that there is. What you see, touch, smell, those are the things that you can kind of seek out and represent. There's nothing like ghosts or goblins or space aliens or God. And therefore,
Well, there may be space aliens, but they would have to be physical creatures.
Right. They're a product of evolution or something that's not demons infesting the earth. So that's the worldview in which some scientists, these scientists in particular, are looking at the world through. And so our claim is, when we tend to study these things, is why do we believe your worldview? So again, we're coming upon worldview questions. It's not just the sake of, well, science. Everyone agrees science works. We all think science is really nifty, and so what the scientists say, that's the gospel truth. And so if they say, well, all these things kind of bring up a cumulative case of no God, then it seems like there's no God, and so you kind of just throw up your hands and you're like, well, the people making the toasters and the electricity and the supercomputers, they're really smart, and so it's the Yuri Gagarin thing of I went out into space and I didn't see a God. Well, he was out in space, so he probably knows more than we do. So we're again having to understand that people look at the world through certain spectacles, through certain presuppositions and assumptions, and we have to understand that even scientists do this.
Yeah, good. Yeah. So, science, what science tells us about the physical world is true is what the suggestion is. He says, and there are good reasons to doubt this, reasons that align with the sober skeptics. And so now he's back to his sober skepticism. Which is what we want to be, yes. Stance towards matters intellectual. To put it differently, he says, there are good reasons to doubt the connection between the truth of a scientific theory and its ability to work to accurately describe the observable world. Or to put it even more differently here, there are good reasons to be what he calls an instrumentalist. That is, to believe that theories need only be empirically adequate to be counted as successful. In other words, theories only need to be able to allow us to explain our observations, the physical observations, the phenomena that we see. That's empirical adequacy, and in order to be successful. Not that they need to be true.
Right.
Right?
Yeah. So if a few episodes ago, half a dozen, we talked about the billiards ball striking. If we didn't know or didn't have any idea what might cause the ball to move away from the other ball once it struck, and you heard that snap, there might be a good reason to suggest that little gremlins are on the other side of the ball pushing it, and so that snap is them giving their 1, 2, 3, and so the instrumentalist would say, well, if that gets you to a useful statement of moving along.
Yeah,
your
if it allows
theory.
you to predict that the next time the ball hits because you believe there are gremlins pushing it, then okay, we'll just say that's fine.
Right.
It allows us to have some predictive power with regard to that particular the gremlin theory.
Yeah, ball pushing. Yeah, exactly.
Right, so he says we should be skeptical of what science says about those parts of the world that we cannot observe because, it's getting at the observation. In other words, it's making a guess, an inference based on what we do observe about the things that we can't observe. And that's just an inference, right? It's an inference from that, and they may or may not be true. Instrumentalism says that they don't need to be true as long as they work. Right, as long as the theory works, that inference works, which is what he called a theory, right? It's then we're good, right? All right. So now what he's going to do in this chapter then is to kind of argue, it looks like here, for instrumentalism. Now again, what we need to make a distinction between the theory and a person, right? Theories are not instrumentalists. Right, there is no such thing as an instrumental theory. Instrumentalism is a person's attitude toward the theory. Right. In other words, here's the theory. So you can either believe the theory is true and is talking about real things, even though we can't see them and observe them, that really do exist. Right. We call that realism. Or we can say, here's the theory, and it works, and it allows us to predict and to explain, and we call that instrumentalism. And instrumentalism says we don't care. That's the attitude. We don't care whether or not it's true or the things that it's positing that exist are true. So this is an attitude toward theories. It's not the theory itself that we're looking at.
So like gravity. Gravity, Newton comes along and says, here's gravity. Well, Newton isn't quite sure what gravity is, but he can measure a universal constant of gravity and all that. And so is it a particle? Is it a wave? Is it a basic building block of the universe?
Is it some force?
Yeah, is it a product of spinning objects? I mean, that definitely was in contention there. And so the person who wants to say, well, what is gravity, has a different take on that question than the instrumentalist who says, what can gravity kind of do for me? Like, what
can the theory of gravity, positing that gravity, whatever it might be, exists, what can that do for me?
Let's take it like a particle and a wave. What do I get out of that? And so we've actually advanced that theory more. Yeah. But whether or not we're talking about truth versus kind of a utilitarian, is it useful? Those are two different things that, again, like you said, we want to make clear that the theory is kind of almost separate from the observer. Yeah. All
right, good. So his first issue here is what he calls the pessimistic induction.
Yeah, really pessimistic.
So sometimes this is called the pessimistic meta-induction because we're doing an induction on induction by looking at the history of science.
That is meta, yes.
Right. So it says one of the reasons to be skeptical is that, as we saw in the last chapter, theories are underdetermined by observation. Right? The observation doesn't necessarily tell us which theory is the correct theory.
Right. It's not like 2 + 2 equals, all right, well, let's plug and chug. 1, nope. 3, nope. 2.5, nope. 2, oh, bingo, that's it. That's the only answer it can be. But here you have, gravity is a particle and a wave. well, maybe it's not even gravity. Maybe it's just something that we've observed, that we've labeled it as this. And so here's, chromium. Chromium is a basic element within the universe, the ether that attracts things. And so it's something that we're not even aware of, but because of pumping all of our kind of putting all our chips on the table for gravity, we're kind of invested in that until something comes along and says, oh, well, here's something that's, generating its own gravity that isn't expelling, heat, or it's fully adequate in its energy production. Well, then we'd have to rethink of our entire understanding of what gravity is. So,
right. Yeah. So under determination, right? He says, we saw in the last chapter, the theories are determined by observation. After all, different, equally empirically adequate. That is, right? The theories meet our observations. Yeah. They're empirically adequate. Different empirically adequate theories can say conflicting things about what goes on behind the scenes. And of course, the big example is Copernicanism and the geocentricity of our solar system, right? Both theories matched the observable data for decades before Galileo, he says, turned his telescope toward the heavens.
And realized that Jupiter had moons circling around it rather than us.
Yeah.
And we took offense to it.
Yeah, that's right. We're no longer the center, right? What's up with this, right? He says, so here we have two theories, both Copernicus theory, the heliocentric theory, and the geocentric theory, right, that match the observation. All their data, right. All the data was the same, and they both. In fact, he says the tectonic theory also did the same thing, right? Tycho Brahe is known for this tectonic theory. So here's the issue, though. During this time, proponents of each theory had to appeal to virtues other than empirical adequacies, virtues like simplicity, conservationness, and such, in order to determine which theory. But there are many more examples of real life underdetermination. In fact, he says the history of science is littered with the remains of successful but false theories, right? Theories that match the available observations, contributed to technological advances, and even made novel and surprising predictions. And yet now we say,
well, those were wrong.
They were wrong.
Yeah.
They were wrong.
Yeah. They weren't ever true. They were always wrong.
Right.
But they were useful.
Yeah, they were useful. They worked. They matched the data. They matched our observation, right? They were successful. They advanced technology. That's right.
Sure.
But they're wrong.
Yeah.
Right? And so he gives us he gives us a list of them. In fact, he gets this list from Larry Loudon, who is a philosopher of science, right? And he gives us a whole list of them. Philistine, the caloric theory of heat, vital force theories of physiology, right? The idea that somehow our physiology has some vital force that's causing life and that sort of thing, right? Spontaneous generation, that's an old outdated theory, although I think it's making a comeback. Right?
Punctured equilibrium.
Right. The optical ether, the electromagnetic ether, all those types of things. In fact, he says we could even add Newton's theory.
It was one of the things. I remember being in Physics 2 class, and after doing, motion and electromagnetism, you move on and you do the second one, and we're talking about Newtonian mechanics, and the professor's up there and just makes a general statement about Newtonian mechanics is like it's helpful, but it doesn't quite get you there. And wait, hold on, all that we've been studying it throughout high school. I mean, once you learn bodies in motion, you're there. All of high school, all of elementary school, even, and then we just paid hundreds of dollars for you to teach us before, and you're saying it's not true? And he was like, no. I mean, the class went up in arms. We came upon this realization. No one warned us about Newton was wrong. I thought we studied Newton even in a modern worldview and philosophy of science. You're telling us it's wrong? No. Okay, it is.
Yeah.
We've replaced Newton. And sadly, Einstein killed him. Although someone might kill Einstein here.
Yeah. In fact, he says in some cases, false theories were more successful than true ones, like this, the idea that he gives us with regard to the ether theory, which was, claimed to be the most validated theory at the time.
Yeah.
Right? Everybody believed that the electromagnetic ether did indeed exist,
Yeah.
right? In fact, so much so that they believed it over the atomic theory of nature.
Yeah.
Right?
Yeah. He has this quote from J.C. Maxwell to the effect that ether was a better confirmed than any other theoretical entity in natural physiology.
Yeah, philosophy, rather.
Oh, yep.
Yeah,
philosophy. That one too.
Yeah.
So yeah, it's what is space? Well, space is nothing. Space is just is there. Okay. Well, what's the difference between the Earth and the Moon? Well, 93,000 miles. Okay, but what's in between there? Well, nothing. Okay. Well, what's the difference between space between my two fingers? Well, nothing. Okay, so there's got to be something there. So this ether theory, which came crystalline spheres.
Yeah. What is moving light through space, right? If it's light, our waves, well, we know that it has to be some medium that's moving it, right? So, for instance, on Lake Michigan, near where we live, right, there's waves in the water that are moving through waves. So, ether positive, there must be ether waves that cause the light to move in waves, right?
Makes sense.
And so that's what's moving the light, right? And everybody thought, oh, yeah, that makes sense, right? Yeah,
for hundreds and hundreds of years. Yeah. So it's not that they were stupid, but it seems, though, that, again, as the instrumentalists would say, it was useful.
Yeah. In fact, he says the great Lord Kelvin said in 1884 that ether is, quote, the only substance we are confident of in dynamics.
Good.
There you go.
The only one.
Yeah. Of course, about 15 years later or so, they discovered they couldn't find it. It didn't exist, right?
So you can't take an ice cream scoop up
More
there and
Maxwell.
get some ether.
Yeah. All right. So notice, here's the issue. If the history of science really consists of a succession of increasingly successful theories making radical and fundamental difference, claims about what there is in the world and how it works, why on earth would we suppose that this process has come to an end with the theories that we have today?
Yeah.
Right?
We know evolution is true. Get over it.
That's right.
Yeah. Well, here's a half-page list of all the theories that we knew was true too, and all of a sudden, we went through a revolution, and now we don't believe those things.
Yeah.
You just it's kind of the better response to, well, evolution is just a theory, right? Evolution is just theory as it exists right now, but again, how do you look at things? What are the presuppositions that you take on that? And is there something better in the future where will the sun rise again tomorrow kind of deal? We kind of have to take an inductive look. Well, evolution, the theory works right now. Well, how do you know that the theory works tomorrow? Well, you don't.
Yeah. So he says, given what we know about the history of science, it seems that we should at least be wary about how much stock we put in current theories, given the frequency with which theories are overturned. In fact, this argument, and now he uses the name, he calls it the pessimistic induction, we can call it. It's also called the pessimistic meta-induction. Seems a wholly appropriate stance for the sober skeptic, right? As one philosopher reminds us, there's always the possibility that Lucy wouldn't pull the ball out of Charlie Brown's way, but Charlie Brown had good reason to be skeptical.
Right. Hopefully, the young crowd that watches us understands that.
That reference, right, to Charlie. Who is Charlie Brown? Yeah. All right, so that's one issue. The issue here has to do with the pessimistic induction, right? So the question is, just because science is successful, does that mean it's true? And the first salvo in his, case against this is that, well, in the past, there were lots and lots of theories that were successful, but that didn't mean that they were true, right? And so he gives us the pessimistic induction. That's the basic idea of the pessimistic induction, right? Just because it's so, again, and his main point is just because, it's successful doesn't mean it's true, right? His next one he calls unconceived alternatives, and he this idea is similar to what we just saw with this, right? He says there are actually two related arguments for scientific skepticism from the history of science. The first, he says, is the pessimistic induction. The second is this: not only do we have examples of two or more competing theories that match the same data, but we also have examples where the alternative theory was something that we hadn't even dreamed of. Right? So here's a theory that came out of the blue that nobody had even thought of, and now we hold to it, right? He says, and this philosopher, his name is Stanford, right? Is who he quotes here. So P. Kyle Stanford. He says, Stanford calls this the problem of unconceived alternatives, right? For example, in the historical progression of from Aristotle to Cartesianism to Newtonianism to contemporary mechanical theories, the evidence available at each time earlier theories was offered equally strong support to each of the then unimagined later alternatives, right? So we have this theory, but we might have a whole slew of theories that we haven't even thought of yet.
Yeah, right? Yeah. Especially depending on, not just what we know, but what we've developed. Once Galileo puts two pieces of different sized curved glass up together, it suddenly creates a telescope, and wow, we realize that stars maybe aren't as close as what we thought it was existing in, the outer crystalline sphere. Maybe they're really, really far apart, and maybe still, different fluctuations in space-time even causes that distortion.
Yeah, and then he gives us the example of Einstein's theory of relativity wasn't even on the horizon, wasn't even conceived of until he came up with it, right? So there may be countless alternatives, though we're aware of only just a handful of alternatives, right? He says the ancient Greeks could have thought something similar. After all, they could have built pyramids. They could build pyramids and make beer. What else is left, right? Perhaps we're only near the beginning of the scientific story, right? In other words, we think, well, we finally arrived. Well, he says the Egyptians could have thought that too, right?
Oh, sure.
I mean, they could build pyramids, goodness knows, right? But he says we're only near the beginning of this. We could be only near the beginning of the scientific story, with yet millions of years left. Perhaps we're at a laughably primitive stage in science. Well, compared to where we could be in a million years or whatever.
I mean, just look at wealth in the world. It's something that we had to wait almost 200 years ago for the amount of wealth that we had to reach 150% of what we had 1,000 years before that, and then to not concentrate it in the hands of literally it's not even the 1%. It's like the 7 people who were rich at the time, and then you develop a market economy and distribution of work, and then you add wealth on top of that, and so the Industrial Revolution came about that. So almost a century ago is all we've had in leaps and bounds from horse-drawn carriage to automobile to airplane to jet engine to rocket ship to whatever the next mode of transportation is. But even look at where we've come as far as computer technology, and we're now talking about singularity. We're talking about singularity as kind of a human species really early in that idea of what was a microchip. Before that, no one knew what a microchip was. It was resistors and transistors, and you had big tubes, and you just needed bigger tubes until you could compartmentalize and have microscope stuff. So this idea that we're advanced as far as technology has gotten us is something that like Elon Musk and people that work the talk circuits that are really interesting to talk about. But is even human species a predominant one, or are we here only to build the AI that goes out and conquers the universe? Where exactly are we falling? If we look at the scope of human history, it doesn't seem like we've, at least from what our knowledge is of right now.
And the point here is there may be unconceived alternatives that we've never even thought of.
Right. And you just have to get there. You have to just.
So how can we say that the theories we have now are true? Right. Number one, in the past, the theories that we thought were true turned out not to be.
Right.
Even though they worked. And now there may be unimaginable number of theories that are better than what we have now, right? So, it's pretty tough to say, well, the success of science gives us true theories, right? Because, again, what the argument he's making is, no, success and truth isn't necessarily the same thing, right? He talks about skinny branches here. And the idea here, he says, it's clear then that a false theory can work. And moreover, it's possible we're in such a situation now, and this possibility isn't merely an abstract one. The history of science provides us with many examples of false theories that are accurately represented observable phenomena and allowed humans to develop useful technologies, but they were false.
Right.
All right?
Yeah, it seems like we're really bad right now at the really small and the really big.
Yeah.
So we're good looking at plants. Hey, look, that's a plant right there. That's a good observation. Let's talk about plants. Well, let's look deeper at plants. Let's look at the subatomic particle. Ooh, quarks maybe? I don't know. Sure, we'll go with quarks. So yeah, it's kind of the Zeno's paradox. How far down can you get before you're dealing with either nothing or infinity? I mean, how does anything if you keep going down and say, well, what makes up an electron or a proton? Well, quarks make up it. Well, okay, what makes up a quark? If you just keep going down, at what point do you stop?
Right.
Or how does that work? So it seems like we're doing really bad at the big and the small.
So the next question he wants to deal with here is the idea, but these are the best theories ever, right? So before we get into this, why don't we do this? We're long into our discussion.
Yeah, we beat up science really good here. Yeah.
So let's break here. We can pick this up and try to finish up this chapter next time.
Yeah. Mm-hmm. All right. Please help us out by sharing these episodes and telling your friends. Facebook and Twitter, and we're all there. If you're listening on iTunes or Stitcher, please leave us a review because that really helps other people see it. And we also do
subscribe.
Yeah, we also do this on YouTube. If you want to look at Tony's handsome face and block out the other half of the screen, so you can do that. And then I'm always having conversations with people on there as well, to my detriment probably. But if you can help us out with that, that'd be great. And we'll see you next week. So thank you.